It's often a good idea, whenever it's possible, to draw slight pictures or to sketch out ideas when we're dealing with them mathematically. And so there are several diagrams that you might use throughout the course of a probability class that are going to be useful for visualizing what's actually going on. And one of these is going to be what we call a tree diagram. Now, a tree diagram is really going to be useful for combinatorial problems, for problems where you're trying to count up the total number of ways that something can happen. And in particular, it's useful for both developing intuition and then also useful for solving small problems. Really, so what we want to do is we want to lean on the tree diagrams for the cases where they're relevant so that we can use the algebra or use the numerical techniques for cases where tree diagrams are pretty infeasible. And so if we're faced with a small counting problem, then the use of tree diagrams can help us in visualizing out the total number of ways that something might happen. So what is a tree diagram exactly? Well, to form a tree diagram, what we're going to do is we're going to begin with the first decision that needs to be made. So what we're really thinking of here is we're making a sequence of decisions, or we're watching a sequence of outcomes, or something similar to that. Okay, and so we're starting with the very first decision or outcome. And then for every option, what we're going to do is we're going to draw and label a node, right? So we're going to be drawing off different lines for each of these different options here. Then from the end of each of these nodes, we're going to draw a branch for possible options on the second decision. Okay, and so then these are going to lead to a set of nodes that can also be labeled, and you can continue repeating this process until you've recorded all of the decisions that you need to do. Right? Those nodes can then be counted to determine the total number, or you can look at subsets of them to count out particular different kinds of events that meet certain criteria. So let's look at an example of this rather than trying to do it with words. And so what we're going to be dealing with here is we want to select a meal at a restaurant. We have to choose 3 appetizers, 2 mains, and 3 total desserts. And so we want to represent this whole scenario with a tree diagram. And so what we're going to do is we're going to recognize, well, the first thing that we have to do is select out our appetizer. And so the way I always like to start this, I like to start this from one single point here, and then I'm going to draw out my 3 different lines representing my 3 different appetizers, right? And then we can put, say, a little square here. And so this is going to be appetizer 1, appetizer 2, and appetizer number 3. And so now we've dealt with our first decision that we need to make. And then what we do is we go to each one of these nodes and we look at our second decision, right? And so our second decision is, well, what main did we want to take? Okay, and so we're going to draw out a branch for each of these, right? And so there's going to be a branch that leads to main 1, a branch that leads to main 2. Okay, and then from appetizer number 2, we do the same thing, right? So we can either go up to 1, or we can go to 2. And then from point 3, we can go to 1, or we can go to 2. Okay, now, so we've decided on our appetizers here, right? We've decided on our mains here. And now we need to decide on our desserts. And there are 3 desserts that we can choose. Okay, and so then we would have dessert 1, dessert 2, and dessert 3. And so I'll put in 1, 2, and 3. And then we can do the same thing for each of these, right? And it's going to get a little bit crammed in here. 2, and I'll draw that one down a bit. 3, that's 1, that's 2, that's 3, right? 1, 2, 3, 1, 2, 3, and then finally 1, 2, 3. Okay, and we sort of crammed everything in there at the end. But now if we wanted to know how many different meals there are going to be, right, what we can actually do is we can actually count through all of our different options here, right? So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's 18 total different options. But we could also, for instance, say, well, how many of these options are going to have appetizer 1, right? And so there we know, well, to have appetizer 1, we need to be on this part of the tree here. And so that's only going to be represented by these 1, 2, 3, 4, 5, 6 different options, right? we might ask ourselves, well, how many of these are going to have main number 1, right? So main 1, we're going to start with these ones up here. So we get our 1, 2, and 3. Then we also have main 1 here. So that's 4, 5, and 6. And we have main 1 right here. So that's going to be 7, 8, 9, right? How many of them would have dessert number 2? Well, that's just counting the 2's on the end here, right? So that's 1, that's 2, that's 3, that's 4, that's 5, and that's 6. Again, so you could start to break this down, right? Appetizer 1 with dessert number 2, that's going to be up in this top part of the tree. We have 1 and 2, and so forth. Okay, and so the problem with tree diagrams is that even when we're only dealing with 18 total possibilities here, right, they can still get quite messy and quite cramped. And if you plan it out a little bit better, you'll fit them in a little bit nicer. But at the same time, they really are helpful tools to visualize these situations. And when you can draw them, especially if you can just do out a quick sketch, you don't even always need to finish the whole tree diagram. You can start to see, well, how does this break down? That's going to really give you a better intuitive grasp of what we're looking for in terms of these combinatorial style problems. And so they're a helpful way to visualize these types of problems when that's a useful thing to do. So when is that going to be a useful thing to do? Well, like Venn diagrams, they provide useful information on specific problems. They can be used for us to specifically visualize the product rule for counting, but they're also going to provide those further insights into the totals, right? It allows you to break down based on sort of the subsets of criteria you care about. They don't scale well, though. If you have too many options or too complex of problems, you're not going to be wanting to draw those all out. The diagram grows very quickly, and you're not going to want to have to draw it fully to completion if there are too many different options, but you can still draw out the partial diagrams, right? And so even if you have very many different options to choose from, or there are way too many different complications, if you start to sketch it out, sometimes that's going to give you a really good idea of what's going on with the problem, right? And so whether you want the full diagram or not, they still might provide some value to you in understanding what's going on with the problem. Okay, so tree diagrams ultimately are going to allow us to visually display simple counting problems, and if they're applicable, they provide pretty good insight into that. When they're not applicable, you still might want to lean on them as a visual aid, but you probably don't want to be drawing them out to completion because that's going to take up a lot of time and space, and instead, at that point, you should really be relying on your numerical or your algebraic skills to solve those questions.